This is a patient with ischemic cardiomyopathy, implanted with a CRTD and hospitalized for syncope. You can see that this episode was initially a fast VT episode. It required a first burst. This burst was inefficient, and then a first maximal shock was delivered. You can see that there is a change in the rate and the pattern of the arrhythmia. It is now chaotic, disorganized. It is probably a ventricular fibrillation, then a second shock, a third, a fourth, and then a fifth shock is required for a return to sinus rhythm. This tracing will highlight the potential pro-arrhythmic effect of an electrical shock. If you look at the EGM, you can see that initially there is a monomorphic ventricular tachycardia detected in the fast VT zone. The first therapy is a burst, and this burst is inefficient. The burst is inefficient, so there is a redetection of the fast VT, and the second therapy is an electrical shock, so starts the charge of the capacitors. So this is the first shock of the episode. So at the end of the charge, there is a confirmation, and the shock will be delivered on the second ventricular event if this ventricular signal is outside the atrial vulnerable period, which is a window that extends from 150 milliseconds to 400 milliseconds after the sensing of an atrial signal. This atrial vulnerable period has been designed to avoid delivering an electrical shock during the vulnerable atrial period with the risk of inducing of an atrial fibrillation. This is why the shock is not delivered on the second, but on the third ventricular tachyarrhythmic event. Once the shock has been delivered, you can see that there is a transformation from an organized ventricular tachycardia to a very fast, polymorphic and disorganized ventricular fibrillation. This highlights the paradoxical effect of an electrical shock. Of course, it can in many times reduce the arrhythmia, but sometimes, like in this example, it can also induce a ventricular fibrillation. We have seen on the plots that the shock 2, 3, and 4 were inefficient to reduce the ventricular fibrillation. You can see at the end of the chart that there is a 900 milliseconds period, and since there is sensing of ventricular events, the shock is delivered synchronously, but this shock is committed. You can see that the fifth shocks reduce the ventricular arrhythmia. We were not surprised that so many shocks were required to reduce the ventricular fibrillation. Indeed, if you induce a ventricular fibrillation with a maximal energy shock, then there is a high risk that the next shock at the maximum energy will not reduce the arrhythmia. This is based on the concept of upper limit of vulnerability. There is a direct relation between the energy that induces arrhythmia and the energy that will reduce the arrhythmia. So in this patient, we need to consider that this episode is clearly an emergency because of this high ventricular threshold and because of the risk of induction of polymorphic and life-threatening arrhythmia. So in this patient, we decided to implant a coil inside the coronary sinus to change the vector of the shocks and to decrease the ventricular defibrillation threshold.